Okay, so good evening, students. We are discussing today February monthly test structured essay paper, right? So for you, I gave you two structured essays for the monthly test of February. These are the two structured essays you wrote, okay? And the first structured essay is a general one coming from atomic structure and bonding units, and then and then you have another question. The second question is coming from S block. Then you have energetics, those questions. Okay. So yeah, that kind of a creative questions. I mean, generally the second structure they say in A-level paper comes from inorganic only, right? But for this your monthly test, I gave you part of inorganic and part of physical chemistry came from energetics. Okay. Right. So we'll quickly go through the first part of the first structured essay question, which is asking the following questions are related to the elements of the third row of the periodic table. So be careful, Lamai. I saw some of you have gone wrong because they didn't pay attention to this instruction. Okay, so they are asking about the third row of the periodic table. So then you need to write only the symbol of the element. Okay, let's say sodium is a third row element, right? So you need to write, let's say if we need to write sodium as an answer, we need to write Na, capital N, simple A. That's it. Okay, you can't write the word. Okay, so follow the instructions and take it as a lesson today. Read the instruction really carefully and really well. Okay, so the first one asking identify the element that has the highest electronegativity, and they're asking to disregard noble gases. Okay, first of all, Lamani, we will take third row elements. Okay, in third period. In third period, what are the elements you have? You have starting from sodium, you have magnesium, aluminium, silicon, magnesium, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. These are the 8 elements you have in the third period. So you have to give answers depending on these elements. Okay. So now the first question they are asking, what is the most electronegative element out of these 8? So what is the most electronegative element? You know, electronegativity is a periodic property, and across the period, electronegativity increases. Understand? So from sodium to argon, what will happen? Electronegativity should increase. Now, why did they say disregard the noble gases? The thing is this: according to Pauling scale, argon noble gases, they also have some value, but electronegativity definition says ability to attract electrons when they make a bond. So the thing is, argon doesn't make any bonds, right? So then there's a kind of a problem. No? So that's why they are asking to disregard the noble gas. So anyway, we don't pay attention to noble gas number. Okay, so we only focus up to the group 70. So then, if you consider these 7 elements, sodium to chlorine, this one is the one with the highest electronegativity, En highest. Okay, so answer for the first question is this. Okay, so what you need to write is C, capital C, simple L. Okay, don't write chlorine. The name is wrong. You have to read the symbol. And then the second question, identify the element that shows the highest oxidation number. Highest oxidation number. So oxidation number, okay, depending on the compounds that they make. Okay, you will have a great idea about this one once you do P block, right? But before that, even we can kind of get an idea. So anyway, the oxidation numbers for the S block, they have fixed oxidation number. Sodium is having +1, magnesium is having +2, and aluminum is having +3, like that. Okay, and then when you go to silicon, its maximum oxidation number is +4. Okay, so about silicon, you can have -4 to +4, including 0, -4 to +4. Okay, so they are having variable oxidation states. If you take phosphorus again, you can tell it is having -3 to +5. And sulfur, you will learn later under P block, it is having -2 to +6. Then chlorine here, is having oxidation numbers from -1 to +7. So then this will be the highest oxidation number. Highest oxidation number. So then again, for the second question, you have to write the answer as Cl. Again, understand? Cl, the one that shows the highest oxidation number. It is better to give one example. The +7 oxidation number, you can give HClO4 is a good example for +7 oxidation number. Okay. Later in P block, you will study about this more. Okay. So right now, until we do P block, still we can think about the knowledge of atomic structure and get the answer. Okay. Still, this is possible. Then the next question is asking identify the elements that form monoatomic ion, smallest in size, smallest monoatomic ion. That's what they're asking. Okay, so then you have to think about the radius because monoatomic ion. So in this group, in this period, the ions that are formed, you can say sodium plus, and then magnesium 2 plus, then you have aluminum 3 plus, like that. So it should be stable also, no? So you can't write zinc 4 plus. Zinc 4 plus is theoretically obtainable, but in real nature, zinc 4 plus is very rare. So silicon 4 plus. So silicon 4 plus is very rare. So we have as cations these three. Now normally what you have learned again on the atomic structure, cations will have a lower radii than anions. Okay, so in that logic also, you don't have to worry about the phosphorus, sulfur, chlorine, and ions. They will be anyway bigger. So they are asking smallest monoatomic ion. So you have to think about these three metallic ions. Understand? So how their radii is going to change? You know, as with the nuclear charge increases, okay, so their radii become smaller. So the one with the smallest ionic radius is Al3 plus. Al3 plus, okay. But when you are writing the answer, what you have to write is Al, because you need to write the element symbol. Okay, element symbol, not the compound, not the ion. Okay, don't write Al3 plus, you will have no marks. Understood? So answer accordingly. So you can find a similar, very similar question in past paper, 2019 A-level past paper. You can see the first structure, they say first part is again given in the same way. So they asked to write the answers using the second row of the periodic table, lithium to neon. Right now, so we came through 3 questions. Now you got some idea. And look at the fourth one. It is asking, identify the element that has the highest electron affinity. Electron affinity. So you have learned a theory. Okay. So anyway, the highest means here it is representing the sign or the magnetic. Okay, magnetic. Highest electron affinity. Electron affinity, the likeliness for the electron is shown by, you have to say in a period. In a period, highest electron affinity is shown by halogen. Halogen. So that you have to remember as a theory. Okay. So you know this from second period, the most electron affinity element is fluorine, if you consider the second period. But if you consider the third period, then it is supposed to be what? Again, chlorine. Okay. So for the answer for the fourth part is again Cl. And a nice to know point, if they are asked to arrange halogens, Cl is the highest, then fluorine. Then you have bromine and iodine. Okay, so we have discussed this earlier several times. Fluorine is having a relatively lower electron affinity than chlorine because of its smaller size, right? So if you take electron negativity, it is not going to be like that. Fluorine is the one with the highest electron negativity, but electron affinity and negativity are two things. Okay, so you can go to the theory book and revise this one more time. Okay, if I say simply, electron negativity refers to something happens when they make bonds, right? But electron affinity refers something happens for them at their gaseous state atom. Okay, so simply electron affinity reaction for the chlorine is Cl gaseous atom takes one electron and becomes Cl. Cl minus gas. Okay, so this one and electronegativity are two things you can obviously understand. Okay, Lama? So remember, affinity. So it's a good topic that you are seeing in the under the unit 1. And then you can see for 3 questions, chlorine came as the answer. No? And for the next one, identify the element that has the highest second ionization energy. Highest second ionization energy. Okay, so what you know, you can arrange the ionizations according to this order. Okay, so let's say this is your sodium, then magnesium, aluminum, then phosphorus, sorry, silicon, phosphorus, sulfur, chlorine, and argon. These are the first ionization energies. No? So when you need the second ionization energy, what you should do? Come one backward. Okay, because when we do the second ionization, you have to think about the electronic configuration of the previous element. For example, sodium comes to this place. Why sodium is having the highest second ionization energy? This is our answer. The thing is, sodium first ionization energy, it is giving you this configuration. This is the neon configuration. So you are removing the second electron from neon configuration. It is going to be a very difficult process. Why? Because noble gases are having a very stable electronic configuration 2s2 2p6. Understand? So therefore, IE2 will be very large. Understood, Lama? So they all are having gaseous state. I didn't have the physical state, but what I want to show you here, the reason for coming one backward. Okay, so when they ask for an explanation, don't say come one backward. Don't they? You have to explain why we are doing it. Understood? So in this way, for the fifth one, no? Fifth one, your answer is what should be written? You have write sodium. Understood, Lama? Is that clear? Then go to the next question. Identify the element that forms a nonpolar trigonal planar molecule with element oxygen. Nonpolar trigonal planar molecule. Okay. So then you need to think about all the compounds made by them. So if they say molecules, you have to ignore these 3 because they are making ionic compounds with oxygen because they are metals now. And then being metal is not a reason, but sodium oxide is an ionic compound. There are covalent compounds that are made by metals, okay, but I'm not telling about them. So just understand they are forming simple ionic compounds, Al2O3, MgO, and sodium oxide. Those are ionic. Na2O, MgO, then Al2O3, these are ionic compounds. So you can't define any geometry shape for this. And silicon forms silicon dioxide. This is a heteroatomic lattice. So this is also not good to discuss that point. Heteroatomic lattice. Okay, then you have to focus on this. Argon is not an option anyway. So phosphorus is forming P2O5. Sulfur is forming SO2, SO3, several compounds. This one is forming a range of compounds, Cl2O3, like that you can go on. Right? So, but you can see obviously what is going to be your answer. This one. Why? It says trigonal planar and it has to be nonpolar. This is a very famous molecule you draw in your second unit, not right? Trigonal planar nonpolar. So then what you need, don't write accidentally SO3 only. What you need to write is sulfur for the answer. Understood, Lama? It's about practice now. You can't draw everything and get the trigonal planar one. So practice more and more, then you will get better at this. So I hope you remember and understand these points that we have discussed now. Okay, so if you have any doubts, Lama, now you can put them into the chat. I'll look into that and give you an explanation. Okay, so I'll share the marking scheme also with you. See, these are the answers. This is the way you have to write. Okay, so now let's discuss the part B of this first structured essay question. Part B. Draw the most acceptable Lewis dot dash structure for the iron. They have given a formula and its skeleton is given below. So what you have to notice is there is a negative charge. Okay, so there's a negative charge for this molecule, for this iron. Okay, and they have given you the atomic skeleton. So there are 3 chlorine. So there are 3 oxygen atoms around this chlorine, and chlorine is bonded to a sulfur, and there you have hydrogen bonded to sulfur, and you have carbon and nitrogen atom. Okay, so think, and you have to leave only one negative charge in this whole molecule, whole ion. Okay, because the central atoms are fluorine, sulfur, those can violate octet. So until they have no charge, they make bonds. That's with the practice. So now if you think a little bit more, right? So what is the most suitable place to keep this negative charge? What is the most suitable place to keep this negative charge? It is on oxygen, because oxygen is the most electronegative element. Okay, most electronegative element. So then you can keep this negative charge on oxygen. So when oxygen keeps a negative charge, it keeps 3 lone pairs and it don't make any double bond. So when oxygen doesn't keep any negative charge, then it is making a double bond. Understand now? So now you can understand how these 3 oxygen atoms are making bonds. Okay, don't follow the Lewis method and anything. So it might give you confusing answer. Best way is to use your practice. Now, if you don't have enough practice, don't start everything from this question, right? So you have many questions before this. You have a theory tut and the paper explanations done earlier. You can easily access them through our Google Classroom and go to that and do those papers one more time. Okay, at the end, by the time you are finishing that discussion and practice again, you will be able to do this question like a normal way, like in the normal way. That means without the Lewis method. Understood? Right. So like I said, here I'm choosing to keep the negative charge for this oxygen. There's no rule. You can keep it for any oxygen. And other oxygen atoms should make double bonds. Now if you check about the chlorine atom, okay, it has made 6 bonds. So making 6 bonds is not enough for chlorine, because chlorine is having 7 valence electrons. So that means there must be another double bond with this sulfur. Understood? Because chlorine must make, that's another point. Cl must make 7 bonds here. Here, okay? Or it can form 5 bonds and keep a lone pair. But for this molecule, it should make 7 bonds. Otherwise, chlorine will get a plus charge. That's not healthy. Charge should be minimized as much as possible. And then think about these 2 carbon and nitrogen atoms. So normally, when carbon and nitrogen comes in this way, usually it makes a triple bond. That's the best way to keep them neutral. Understand? They make a triple bond usually. So now let's put a triple bond there and a lone pair on nitrogen. So don't forget lone pairs, okay? Now the carbon and nitrogen both are happy. Now think about sulfur, don't stop, right? Now think about, this is a good question. Now think about sulfur. On sulfur, you have only 4 electrons, but sulfur should have 6 valence electrons, isn't it? So put a lone pair, then everything is okay. This is the way you have to try this question. Understood, Lam? You can start by doing Lewis method also. I'm not telling it's wrong, right? But it will take more time. So that time problem will affect you in your next few questions also. Okay, understand, students? Now, so try in this way. Try in this way. So I'll show you the marking scheme. Here you have the same answer, and I offered 12 marks for that. Understood now? Right, now let's go to the next part. Now depending on the structure you have taken, it's asking to state the oxidation numbers of Cl and sulfur atoms in the structure you have drawn above. Oxidation numbers of chlorine and sulfur. Now, oxidation number refers to the number of electrons lost or gained totally or partially. Now, this is a molecule, this is sort of an ion, but the central atoms, they have made bonds, covalent bonds. Now, then electrons are here exchanged or gained, shared partially. Okay, partially. So partial gaining, partial losing. So you can easily represent that one by marking dipole moments, right? So for each bond. And here oxygen is more electronegative, so it's attracted between, if you can consider between chlorine and sulfur. Okay, if you consider between chlorine and sulfur, if you consider between chlorine and sulfur, what is more electronegative? What is more electronegative? It is chlorine. This chlorine. So then chlorine will accept partially 2 electrons from sulfur. Now, if you consider chlorine, it has gained 2 electrons partially. It has gained 2 electrons partially. And it has lost how many electrons? 5 electrons partially. Isn't it? It has lost 5 electrons partially to oxygen. So then the total electron exchange is, it has lost 3 electrons. So that means oxidation number is plus 3. Understood? That's for the chlorine. And then write about sulfur. Now sulfur, I mark 2 bonds, and sulfur is more electronegative than hydrogen. But when you consider carbon and sulfur, I told you, okay, sulfur is the one with more electronegativity. So then you can point it in that direction. Okay. Yeah, you can take carbon is also more electronegative, because the thing is actually according to Pauling scale, both are having 2.5 values. Okay. Carbon, sulfur, they both have the same value. Iodine, they both have the same value. All three are having the same value. So then you will be given marks for all the possibilities, right? And anyway, so you have to have one way now. So take sulfur as more electronegative. So in that case, sulfur here lost 2 electrons and gained 2 electrons. So there is no overall gaining or losing. So oxidation number is 0. Understood? So if you consider carbon to be more electronegative, then oxidation number is plus 2. Okay. Oxidation number is plus 2. Right, anyway, I think in the marking scheme that answer is, yeah. So anything is accepted. See, other options are also given. Okay, so then you need to know why the plus 1 is getting. You will get plus 1 if you consider carbon is more electronegative. You will get plus 2 if you consider both are equally electronegative. Then you will get 0, because there's no electron exchange between sulfur and carbon if you consider both elements to be same electronegativity, having same electronegativity. Okay, understood that one properly, Lamai, about oxidation numbers. You can't write multiple answers in one space, no? So select 0. Okay, because you are considering, according to your syllabus, you have to consider sulfur as more electronegative. Right. And then the next part is about drawing resonance structures. Okay. So now this question, this structure is kind of a special one. Why I'm telling that one? Because Lama, you can see one of the central atoms here is sulfur. So when sulfur comes as a central atom, it's kind of special. Why? Because it can violate octet rule and it can make more bonds. It can keep more electrons than 8. Understood? Now look at the structures. Now the one they have given, the sulfur is following the octet rule. Here, sulfur is following the octet rule. You can see 8 electrons are there around sulfur. No, it's not following, right? Sorry. There are more electrons. You have 4 bonds and 1 lone pair. So it has 10 electrons. Already have violated octet. Okay, so that means when you are drawing the structures, either you can keep the octet or violate the octet. You can see multiple structures I have given you, but I'm asking for only 2. That's another thing that will happen. Sorry, only 3. That's another thing that will happen in the exam. When you have sulfur, phosphorus, or something, chlorine, like a third period element as the central atom, you can draw multiple structures. You can draw more structures than I gave here. Understand? Because you can keep triple bonds, double bonds. If you need, you can keep single bonds and 1 lone pair. Those are also correct. Now look at this structure. Look at this structure. Here you have a single bond. All are single bonds around sulfur. But still, this is a correct structure. But be careful about nitrogen atoms. Those can't violate octet. You know, the elements CNO, carbon, nitrogen, oxygen, they can come as the central atoms in these molecules, right? And in each case, they must follow octet rule. They can't violate the octet. CNO must follow octet. Remember that. Okay, CNO must follow octet. Right now, in this way, you can draw multiple structures. I hope you got it okay. And if you got wrong, see whether any lone pairs are missing. See whether the overall charge is not equal to the molecule charge. So this is a molecule. That means there is no overall charge. So whatever the structure you draw, after you are drawing, check whether you have any overall charge given. Okay, so this should have no overall charge. Now look at the structure that I have marked here. There you have 2 plus charges. That means at some place you should have 2 minus charges. That must happen. Even violated octet or without violated octet, that must happen. Charges must be same. Understood? Because resonance structures are the alternative structures you can draw for a given molecule. Then the given molecule properties must be preserved. So electrical neutrality is a property that has in the original structure. So that property must be preserved. That property must be kept without changing. So follow those advices, Lamai, and I think I'm highly recommending you to go through our previous paper discussions, especially when we are doing this lesson, you need to we did all the past paper structured essays in this class. Okay, 2019, 20, like that, we continue to do. Understood now? Right. Right. Now the next thing is about the usual table. I hope most of you are doing this really well. And yeah, it is asking about Vesper pairs, electron pair geometry, shape, and hybridization. Okay. So the thing is this, Lam, just you need to know how to calculate the VSCPR pairs. Again, I'm recommending you to go through the earlier recordings because there I have discussed in more details. I remember in one essay question, one structured essay discussion, Lamai, I repeated whole hybridization theories with an example. Now, like that, we have done some resourceful discussions. Okay, so go through them because I noticed some few students are still struggling with the table. That can't happen. Okay, right. So the thing is, the way you need to calculate the repulsion unit, that's where you should start. So let's take this sulfur atom. Let's take this sulfur atom. So around sulfur, you can see one lone pair is there. And here you have a bond pair. And here you have another bond pair. Okay, because there's a triple bond, we know, but we consider triple bond as one unit. So there are 3 repulsion units around that sulfur. That's why we have 3 VSCPR pairs. Understood, Lama? So then if you take the nitrogen atom right here, this nitrogen, you have only 2 repulsion unit, a triple bond and a single bond. Okay, so triple bond is treated as one unit, no? Okay, and then you have for the N3 nitrogen, you have 4 repulsion units, 3 bonds and 1 lone pair. Like that, know how to calculate the number of repulsion units. Okay, that's a better way. Understood? And then, depending on the number of repulsion units, you can decide the geometry. Now, let's say you have 2 repulsion units. If you're having 2 repulsion units, then they will be arranged in the space in linear geometry, keeping maximum angle of 180 degrees. Understood? Then let's say they are having trigonal, there are 3 repulsion units, then the least repulsion will be there when they are arranged in trigonal plane in 120 degree angle. Okay, so like that, you have certain arrangements for depending on the number of repulsion units. Okay, so trigonal planar, tetrahedral, like that, they are because to minimize the repulsion between the units, because each unit we described earlier, the lone pairs, the bond pairs, they all contain what, Lama? They all contain electrons. So electrons are negatively charged. So one unit, the negatively charged units must be minimizing their repulsions, isn't it? Then only they can become stable. That's why this thing happens. Always know the reason, then you will remember it for a long time. Now for the shape, when you are having 2 bond pairs and 1 lone pair, then the shape is going to be angular, or you can write bent, angular, bent, or you can write V shape also, V, that also accepted. But don't write, okay? Write angular or bent for the exam. Don't need write both, okay? Selecting one is enough. Angular is also correct. And then for the, yeah, like that you can continue, you know, the story. And the next one, about hybridization. About hybridization. Now the thing is, Laman, the one way of remembering this one without knowing any theories, okay, you can just memorize. Okay, but I'm not recommending that. But for the last resource, that's the thing we need to do. If you can't understand, if you can't remember this properly, if you're not studying, at least what you need to do, memorize this. So if you are having 2 repulsion unit, it is SP. If you're having 3 repulsion unit, it is SP2. If you're having 4 repulsion unit, it is SP3. Right? You can just remember. Okay, so the things that are having trigonal plane electron pair geometry will have SP2 hybridization. Like that, you can remember. But what is the real reason behind this? What is the real reason? So now you can notice. I'll bring to your attention this C5. C5. This is also trigonal plane. No? Look at the molecule. Look at the molecule. Look at the atom. So how many bonds it has made? It has made 2 sigma bonds with either side nitrogen and carbon, and then it has made a double bond with oxygen. So in that double bond also, one bond is a sigma, other one is a phi. Okay, so around the carbon I have marked here, how many total bonds are there? Okay, there are 4 total bonds, but out of those 4 bonds, one is a phi bond. 3 bonds are sigma bonds. Okay, so now remind what is a phi bond. In a phi bond, lateral overlapping will occur between unhybridized p orbitals. Okay, I'm repeating it again. Lateral overlappings are occurring between unhybridized, that means the orbitals that didn't went for the hybridization. Or you know the p orbital, the dumbbell shaped one. Okay, so there are 2 dumbbell shaped orbitals side by side and overlap. That is a pi bond. Okay, one orbital comes from carbon, other orbital comes from oxygen. Then only they make a bond. No. So that my point is, Lama, if you consider the carbon electronic configuration, carbon orbitals, it has 3 p orbitals. Okay, and it has 1 s orbital. Okay, so 2s2, 2p2. The 2s orbital is there, and there are 3 2p orbitals. So out of those orbitals, Lamai, there are altogether 4. No? From those 4 total orbitals, you have to keep 1 p orbital without being hybridized. Because when they went for the hybridization, they can't make 5 bonds. Understand? So that's why the hybridization has become sp2. because only one s orbital and two p orbitals are hybridizing, joining together to become sp2. So the remaining p orbital will be there as it is to make a pi bond with oxygen. That's the real story, but that take a lot of time to understand. That's why if you are still struggling, at least remember when you are having three repulsion units or when the electron pair geometry is trigonal plane, it must be sp2 hybridized. And there are more things, there are more advanced points we have discussed on this one. I'm not going to tell them here, but anyway, I'm again encouraging you to go through our previous recordings of the paper classes, okay? So if you are especially been preparing for a test or something, you must do it. You must do it several times. You don't need to do anything else. You already have done every possibility that can come to your test. Understood? Okay. Now we are taking a level up by discussing this monthly test papers, by doing monthly test papers, because that will be something like you are writing a term test every month. Okay. Right. So anyway, this is about the table. I noticed still some people are struggling with hybridization. That's why I took some time. Right. Then the next part is okay. No? You need to write about the orbits. So then if it is a peripheral atom, terminal atom, you have the freedom to choose either hybridized or unhybridized, but be careful. Let's say if it is a phosphorus atom, let's say this N1 is phosphorus, then you can't write 2p, then you have write 3p. Isn't it? Those are the valence orbitals. So like that you can continue. And yeah, so one special thing is there about the 5 bonds. Okay, so I'll explain that part in the board. Okay, one special thing is there about the 5 bonds. Okay, now the structure is N triple bond sulfur, and there's another lone pair, and nitrogen and hydrogen. This is the structure. It continues, but we have to focus on this sulfur. We have to focus on this sulfur. Now look at this line. Now the hybridization of sulfur. Now this sulfur is having 3 VSC-PR units. Now according to what I said you earlier, this is trigonal plane, and hybridization is sp2. sp2. Okay, so according to sp2 hybridization, you have only one p orbital left to make 5 bonds. But how many 5 bonds this sulfur has made? Sulfur have made 2 5 bonds. Okay, so that means the p orbitals given by sulfur is not enough. Understand, the p orbitals given by sulfur is not enough. So then how this other 5 bond is made? Okay, so that is made by d orbitals. Okay, sulfur is having d orbitals. Okay, where sulfur is having d orbitals? But you can't see that one when you write ordinary electronic configuration. Let's say full configuration is this, no? 3s2, 3p4. Now you are not seeing any d orbital, but since it is having the third energy level, it is having 3d orbitals, but those are empty. That's why I wrote 0. So now this is the valence shell. Now these are the co-electrons. These electrons are not participating in bonds, but valence electrons are participating in bonds. Okay, so now what will happen is they will be excited. Now here you have 5 orbitals now. Now earlier it was fully completed. I mean, like this. Okay, so now what will happen? One of these electron will jump to the d orbitals like this, and these 3 will undergo sp2 hybridization, and these 2 can make 2 pi bonds with whom? With nitrogen. Understood. So that's why in your answers, when they're asking what are the orbitals made pi bonds, you have to write the sulfur, one pi bond is made by a p orbital, 3p orbital, and the other pi bond is made by a 3d orbital. So understand that is a good concept, but may or may not be asking in the exam, but still it's a good point. Okay, I have discussed this point again in our earlier paper. Okay, so now look at the answers. You can notice that, me. Can you see? It is 3D. 3D. Understood? So I think it is a good point to remember. And then in the next one, it is asking for you to arrange, state approximate bond angles. Approximate bond angles for these atoms N5, N3, like N3, C5, like that. So now if you go back to the geometries. Now, N, are they asking the same elements? N S2, N3? No, they are not asking about sulfur. Okay, anyway, if you go to the N3 is having a tetrahedral molecule, tetrahedral geometry, but pyramidal shape. So if it is tetrahedral, ideal bond angle is 109.5. And you know, for one lone pair, you need to subtract 2.5 degrees. So after you have subtracted 2.5 degrees, the bond angle will be 107. 107. Understood, Lama? So that's why for the N3, I have written 107. Then C5 is a trigonal planar molecule, and you can see they all have bonds, and there are no lone pairs. So ideal bond angle for trigonal planar is 120. So you can approximate, as the approximate angle, you can take that. Okay. And for the I think C7 is there. C7 also the same, 180. And N8 is also 180 because both atoms are linear. If they are linear, anyway, they're going to be 180 bond angles. No change. I mean, bond angle can slightly vary depending on the peripheral atoms and the electron density in one repulsion unit. That can change, but they're asking here the approximate angles. So you only have to change the angle when there are lone pairs. There are no lone pairs, just say the ideal bond angle as the approximate bond angle. No problem. Okay, Lama, understood? And then finally, they are asking you to arrange them in ascending order of the electronegativities. Okay. So if you go to the electronegativity, this sulfur, nitrogen, C5, C7, and another nitrogen. Now, first of all, arrange them in ascending order of their elements, electronegativities of element. As you know, sulfur is more electronegative than carbon. So in that case, C5, C7 should have lower electronegativities than S2, and nitrogen should have highest electronegativities. Then think about the atoms of the same element. Now, if you take two carbon atoms here, C5 and C7, I hope you remember C7 is sp hybridized. So then its S character is higher. So that's why C7 is more electronegative. And the same logic is applied for nitrogen, N8. N8 was also sp hybridized. So then S character is high. So you know when you have more S character, that element atom will become more electronegative than the same element another atom. Understood? So in that way you can arrange. So first of all, arrange them in element form. Carbon, sulfur, nitrogen. Then think about the same element atoms. Okay, do this properly, otherwise you will get a wrong answer. Some students are there, they just consider the S percentage of all the atoms. So it's not going to give you a proper answer. First of all, separate elements, then separate atoms of elements. Write that somewhere. And again, Lamai, we have done enough questions from this topic. Right? Understood? Okay. Now let's go to the second structured essay. second structure they say. I'm going to quickly discuss that too. And here they have given a small paragraph and you are asked to identify the elements. I'll tell you what to think and how to think. I'll make it short. And it says A and B are metals of S block with water. A reacts slowly and B reacts vigorously to produce solutions C and D. And a colorless gas E. So then when S block elements are reacted water, they are producing a gas. That gas must be what? That gas must be hydrogen gas. So E is H2. E is H2 gas. Okay, so but we can get a small clue. If A is reacting slowly, that means it can be either magnesium or you can't take anyway beryllium. Beryllium is not reacting with liquid water. It reacts only with steam. Even magnesium is reacting with hot water, but they haven't mentioned any hot water or anything. So then most probably you have to have the doubt here. What they referred as slowly is for the steady reaction of lithium. Maybe you have to guess. Okay, because if you take the group 1 elements, the set of group 1 elements, okay, lithium reacts steadily, or in your resource book it referred as slowly, because it is slow relative to other S block elements. Okay, it's not that much slow. It is not slow, right? Like magnesium. Okay, magnesium is really slow, but lithium is not like that. It is slower relative to the other elements of the group 1. That's why they have mentioned slowly. But anyway, this possible answer is lithium, right? So just take a small doubt. Then if your doubt is confirmed through the next few data, then you can select that as the answer. Right, now look at the next sentence. Both AB reacts with N2 gas. So that means it can't be any other element in group 1, because sodium and others, except lithium, others of group 1 can't react with nitrogen. Okay, and when you added FNG to water, they will form NH3 gas and hydroxide. And NH3 gas can turn red litmus to blue, we know that, it's fine. And then, the next point is important. A and B have the highest and lowest first ionization energies of their group. Okay, so highest first ionization energy is shown by the upper element of the group. That means if it is group 1, highest ionization energy is there for the lithium. If it is group 2, highest ionization energy will be there for the beryllium. Right? So the lowest are for the last element, cesium and boron, beryllium. So cesium and barium. So barium. Like that. And the next thing is also important, red and yellow-green flame. So yellow-green flame is typical for barium. Right? So that means B is barium. So it is the lowest one with first ionization energy. Then the other one should have the highest ionization energy, according to the earlier statement. Then your A must be lithium. A must be lithium, because lithium is the one produces the red color. You can't take beryllium. Beryllium is another one with the highest electronegativity, highest ionization energy. But why we can't take beryllium? Why? Because it is not giving any color for the term test, color for the flame test. So your best answer here is lithium. That's how we select lithium and barium. I hope most of you selected this correctly. But still, practice. Okay, practice. You have to think about several steps together. And the hydroxide, nitrides and everything are there. You can work with the reactions, configurations. And here you have one unfair configuration I know about barium. Barium atomic number is somewhere, I don't remember, it's maybe 50 or something, somewhere around 50. So you need to write it for a long way. But anyway, it is ending with 6s2. Okay, so these type of configurations are kind of rare to be asked in A-level exam. So because your configurations are limited to 30, atomic number 30. Anyway, now this is not a problem because it is S block element. S block elements are usually having a certain pattern for the electronic configuration. But the problem is here you are expect to write the full configuration. When you are writing the full configuration, some might confuse with the fourth and fifth energy level thing. But anyway, still practice on it, because these things can be there in term test, no? And the reactions and everything, like I said, are happening. And the next one, sixth one says, write the balanced chemical equation for the thermal decomposition of A. So A, nitrate of A. Nitrate of A means lithium nitrate. And we have studied the thermal decompositions under nitrate, carbonate, and bicarbonates. Nitrates are thermally decomposing according to three categories, no? Remember? All group 1 elements except lithium. Their nitrates are thermally decomposing to give nitrite and oxygen. So if you take sodium nitrate will give you NaNO2 and O2. But lithium nitrate, group 2 nitrates, and other moderate reactive metal nitrates, they react in this way. They will give you the oxide, NO2 and O2. And there's one more category to that. There is low reactive metal nitrates like silver nitrate. It will give you silver metal, NO2 and O2. Because the oxide is unstable, so oxide will undergo further decompositions. Understood, Lama? I'm telling everything, so you can just quickly revise them if you are looking at the note. Okay? And carbonate thermal decompositions are also the same, similar way. These are second category carbonates. Anyway, give you oxide and carbon dioxide. And make sure you are balancing them. No need to write the physical states for inorganic. And yeah, this arrow is also not necessary. I mean, the triangle is also not necessary. We are putting it to indicate thermal decomposition. And there's one theory asked later. Giving reasons, explain the variation of thermal decomposition temperatures of carbonates of group 2. Be present means group 2. So first of all, you have to tell what would happen to the group 2 carbonate thermal decomposition temperature. Now, it is becoming difficult to thermal decompose. Thermal decomposition temperature increases. Why? Because downward the group, ionic character of those ionic bonds increases. So if you start from magnesium or beryllium, let's say magnesium to barium, right? Ionic radius increases. So as a result, my polarizing power decreases. So if they are having lower polarizing power, then they can make good metallic structure. Sorry, they can make good ionic bonds. Ionic character is more. So that's why it is difficult to decompose. Understood? Or you can explain this one using electronegativity difference too. As you go down the group, electronegativity decreases. So the difference of electronegativity increases. Because when we are getting the difference, we always subtract metal electronegativity from non-metal electronegativity. Here the metal electronegativity is the one that are decreasing. No? So then you can easily take that electronegativity is increasing, difference is increasing downward, the difference is increasing down. That explanation is also suitable. Understood, Lam? But in the marking scheme, I gave you about the polarizing power because that is the most recommended way. In exams, they can ask specially for you to write using polarization and polarizing power. So then you don't have any option. You have to do it. Okay, and the next question I gave this time, the part B, I gave you a question from energetics. I gave you a question from energetics. Look at the question. Now here you are mixing two solutions. One is a base and the one is an acid. Okay. And here most important point you need to notice is some students miss the total volume. It's not 120. You are mixing two solutions of 125. So total volume is 250. Sorry, 250. Okay. And first of all, I'm asking you the reaction. It's acid-base reaction. So they form salt and water. Under neutralization enthalpy, recently you learned this again. And then you need to calculate Q, heat change. Then for the writing formula, I offered some mark. And you are using, they have not given directly the mass now. You have to find the mass using the volume and the density given. So density is for water, then you have to choose the volume of the solution. Then it is giving you 250 grams, but make sure you are showing that one separately. Huh? And then specific heat capacity of water, and then the temperature difference. Understood? So recently we did a MCQ in our class, remember? A 2025 A-level MCQ. In that MCQ, maybe in some classes I haven't done it yet. This week I'll do. So in that question, they asked for the, they gave the specific heat capacity of the solution. So when they say solution, specific heat capacity, without saying specific heat capacity of water or something, then you have to consider the mass of the solution. Now here, you have to consider the mass of the water. So anyway, that's why we took the addition of two volumes and then multiplied by the density of water. So by doing that, we will get the mass of water. So be careful and read the question properly. Those who did that question with me now, you will remember what I am telling you. Right, so anyway, Lama, you will get 13.65 is as the kilojoule value. You need to do the simplification a little bit, no? So anyway, after that, they are asking for you to calculate the enthalpy change, neutralization enthalpy change. So when you are finding enthalpy change, you need to divide the energy change by heat change by the moles that caused. And since it is a exothermic reaction, neutralization is always exothermic. You need to put a negative sign in front. Okay, minus 54.6. And what was the neutralization enthalpy actual one? If it is done under standard conditions, the expected one is what? Minus 57. Remember, minus 57. But now the value is lower than that. Okay, that must have something to do with the mixing, enthalpy change of mixing. Or you can say enthalpy change of like that. You can think different. There must be maybe an error, observation error or something might happen. Understood? So anyway, remember what to do and how to do that. And then in the fourth question, it is asking the assumptions. The assumptions are no heat loss and no volume change during mixing. So that is also very important. Okay, so if the total volume become 249.45 or something when mixing, that can also happen. Then the whole question will be different. No? So you have to use that value as the total volume. So we are assuming that volume is not changing. That is also a good assumption. Remember, I saw most of you have written only one assumption, that neglecting heat exchange. Okay, heat loss with the surrounding. Okay, that part is only the thing maybe one have written. So focus on the second assumption too. Okay, Lama. And then the next one is about the graph. Here it is exothermic reaction, so heat gradually increases. It says it increases up to 40 Celsius. I have to label the axes and everything. And proper shape also must be taken into account. Why? Because the heat rising happens faster than heat losing. Okay, so that's why the slope at first is higher, then the slope is later. The slope is lower later. The heat losing process is happening slowly. Because heat is added quickly with the help of the reaction. But heat losing process is happening slowly because the system need to push away the heat to the surrounding, but that is happening through a plastic container. So plastic is not a good thermal conductor. That's why it is the shape of the slope becoming very low gradient, or then narrow, the slope is lower because of that. Understood, Lama? Because they here system and the surrounding exchange heat slowly. Okay, and system and the reaction here exchanging heat faster. You can write that system and the reaction heat exchange heat faster, and here you can say system and the surrounding exchange heat slowly because of the plastic cup. If it is a metal cup, it will be reach the initial temperature sooner. Understood, Lama? If it is a metal cup and a plastic cup, this is the way you need to draw. If it is a metal cup, plastic cup, this is the way. But if it is a metal one, then the rise is also low. It will be a smaller graph. Will quickly reach the initial temperature for the metal. Because metal is a good conductor, it will exchange heat faster. So then you will get a false observation, right? You might do the whole question by thinking this is the highest temperature, but it is not the actual temperature. That's why it is very important to select some a calorimeter or something that minimize the heat exchange with the surrounding. So as long as you hold the heat inside, then you can see the maximum correct temperature. Okay, so that's another problem. If they ask why didn't we get the 57 value, you can say that too. You can say we didn't use a calorimeter, that's why we didn't get 57. Understand? Because we used a plastic cup, no? That's not enough. So I think you understood well, Lamai. And if you're having further doubts, please you can ask anyway during the class, or you can text me an answer. Yeah, so that's about the structured essay paper. So in next week, we will discuss about our essay paper. And anyway, the March monthly test is coming at the end of this month, Lamai, so be prepared. So like I advised during the classes, try to increase your mark at least by 5 or 10. Right? You can do it, Lama, you can, because go through these questions, because similar ones I have to ask you. Okay, because yeah, in the fifth and sixth units now. So there will be questions from energetics and bonding, atom, calculations, everything, repeating, same things. Okay, so be prepared, then you can fix your doubts, fix your problems, and get a good mark. Okay, so little by little, try to improve. Right. So I'm going to finish the class for today. If you're having any doubts, like I said, you can always ask. And yeah, write a good review for this too. And attach it to your answer script and put it in a file and keep it. Arrange things nicely, Lama, because these things are very valuable. You have taken time and write a paper now. And I have given you the marking scheme and marks to you. And now I'm doing the discussion with you. So it's a fully completed package. So keep these papers safely and study them. Keeping safe is not enough. You have to study also. And yeah, then obviously your grades will be better. Right, so Lamai, good night. Study well. If you're having further doubts, you can always ask, okay?